my screen. Yes, just a quick check. How many of you can see the screen? Click yes quickly. Okay, good. And that also shows how many of you are very active with a yes or no. Okay, good. Okay, clearing the feedback. Uh, okay, so we started with sets, right? Uh, so I am writing a set. Is it, huh? Is it the correct set? I mean, whether I've written correctly? What set is this? Can you answer? Marcy, starting my doubt, you have doubt in the beginning. See, now this is sixth session, right? We have 12 sessions. We are halfway already. Now I should not tell you that when do you have to raise your hand. Okay, you should understand. Yes, room number 1, Payal.
Yes, sir.
Yes, what is the problem here?
Sir, there is no repetition of elements in the set.
But then what is the set?
1, 2, 3.
So can I say this is 1, 2, 3, right? Because in set
Yes,
we do not repeat. Yeah. Okay. Then what about this set? Uh, yeah, sorry, 1 by 2. What I want to say is 1 by 2, and then 2 by 4, minus 1 upon minus 2. What is this set? Yes, room number 4, Swati.
It is 1, comma 1 by 2, or
Yes,
2 and 3.
2 and 3. Uh, how many of you agree with her? How many of you agree with her? Right, so repetitions are not there in the set. I mean, this is the same element, though expressed as minus 1 square, but we know it is 1. And all these are same, right? Different way of writing. So if I write some set like 1, 2, 3, or I write some set like minus 1 square, okay, or and then 2 and 3, these two sets are same. It's just that I have written here 1 directly, and I have written there is some other way of expressing, but the same is set is same, right? Okay. And now I'm giving you one set, and we have to write. So consider this S equals to, um, let's say 1, and then 4, 7. Can you identify this set? Those who can identify set, click yes. We want to write in property. Okay, what are the elements are there? We have to write like this. Why only 17? I want to write in terms of some property. Right, room number 9, Vishal. Room number 9, Sandhya. Yes, room number 6, Maharshi.
Sir, am I audible?
Yes, please answer quickly. Maharshi, tell. Okay, now you're not audible. Let me ask somebody else. Room number 10, Pragya.
Yes, sir. So I didn't know how to write it, but I can tell you.
You can guess. Okay. What are the elements?
Uh,
Do you
so
see any pattern?
x, yes, sir. X such that x plus 3 belongs to x where x is greater than 1.
Okay, so x says that x plus 3 belongs to.
S.
Oh, but we are writing S. How can it be S here also and S here? I don't know what is S. We are writing only S. Okay.
Um,
So,
so that's why I'm saying I cannot write it, but I can tell what is
okay, no
going on.
problem. No problem, Pragya. But can you see the pattern? Like, what will be the next element after 10? Can you see that?
Yes, sir. It will be 13.
Yes, and then?
13,
Yes.
16.
Yes. So, can you see what kind of sequence is this? Can you see some pattern?
So where x is greater than 1 and x is added to 3.
Okay, let us ask somebody else and see if we get better answer. Yes, Shivam, room number 1.
Yes, sir. Am I audible?
Yes, all of you are audible. If you're not audible, I'll ask somebody else. Okay, so just quickly, whenever you unmute, just say the answer. Okay, don't say yes sir, no sir, or am I audible, or just directly say it. Yes. Bolo Shivam. Tell.
X such that
Yes.
plus 3,
What plus 3?
x plus 3.
X plus 3.
X belongs to natural number.
Okay.
X plus 3 or x equal to 1. Equal to 1.
X plus 3 equals to 1.
No, x plus 3 or x equal to 1.
X plus 3 or x equal to 1. No. No. If I take x equals to 2, what will happen? 5 will be there. No, I think room number 2, Adya. Okay, what are this number? How do you get the next number?
Yeah, basically adding the plus 3 in every number. So we will write it as x, where x is equals to n plus 3.
Yes, x equals to
N
n
plus 3.
plus 3. Okay.
And where n is a natural number.
N is a natural number. But if I take n equals to 2, then 5 will be there. But 5 is not in the set. I will not ask
N is
anybody who raises hands. Okay. Wait. Room number 3. Heath.
I was saying that n plus 1 such that n belongs to W, but I thought 5 will be there. So
Okay. Let's take some easy set. Okay, fine. So let's take something 2 square. Sorry. 1, 4, 9, 16. Right. Now I want to write this. I'm clearing the feedback. Okay, we'll keep that for discussion. The other set. Okay, I'll just write here s equals to 1, 4, 7, 10, and so on. This is I leave for discussion. Just want to write like this. Yes. Tell about this. 1, 4, 9, 16, and so on. Yes, room number 5. Jainam.
X such that n square, where n belongs to real number, natural
Uh,
number.
okay, so I can write n square, right? Where n belongs to n. Okay, clearing the feedback. How many of you agree with this? We're just not involving x, just writing n square. Right? Sumit, what is the problem?
Sir, n may be integer also,
If n is, can n be 0?
except 0,
N can be integer also, but what is the
but not
problem
equal.
in this? If I say you this set and you try start listing, do you get this?
Yes.
So it's
This is
no
also
problem. This is correct, yeah. Who else has a problem? Siddhi, yeah. Change the answer. Okay, good. Okay, fine. So this is also way to write. Now my question is whether 45 is there in the set or not. Not this one. So let me write S dash. Okay. Whether 45 is in S or not, and if not, why not? whether 45 will be here. If you are saying no, say no. If you're saying yes, say yes. Firdaus?
Yes, sir.
Yes. What is your answer?
45 does not belong to S as it is not a perfect square.
It's not a perfect square, but any other reason? How do I write this? 45. Why it does not belong to this? Okay. Room number 7. Azka?
Yes, sir.
Yes. Why 45 is not in the set?
So because 45 is not a perfect square, and we cannot take any n and multiply that n with the same
Yes.
number, so we
Yes.
cannot get 45.
Yes. See, we are not describing this as perfect square. That's fine. But what she said, you cannot take any n. So given any n, right? Given any n in n, you cannot write 45 equals to, given any n, 45 is not equals to n square. And therefore 45 does not, because what type of elements are there? N square, right? And for n in n. So given any n, 45 is not equals to n square, and therefore 45 is not in the set. How many of you agree with this? So now I've given you 45, but if I just give you some x, what do you mean by x is not in S? X is not in S if now I want to write instead of 45, some x is not in here. Yes, room number 2, Anwar. Anwar, you are not audible. Pritika, room number
Yes,
3.
sir.
Yes. What
So
do you mean
for
by
all,
x? Huh?
so for
Yes.
all n,
Yes.
there won't be any n square
For all and where?
in natural numbers,
You have to be precise. Yes. For all n in n.
such that n square does not belongs to S.
Not n square. We are talking about x. X is
X.
not in S means what? Given any n in n.
That we cannot find such a x square,
Such,
n
so
square,
x is not equals to
n square.
n square. Is it clear? 45 just I have written instead of 45, I have just written n x. So x is not here. That means I cannot write it given any n. I cannot write x equals to n square. So what does it mean by saying x belongs to n? Clearing the feedback. What does it mean by saying x belongs to n? Sumanyu?
So X belongs to S if there exists an N in
Yes.
the set
If,
of naturals such that X is equal to N square.
yes. If there exists some n, right? Some natural number n such that x is of the form n square, then x is in the set. How many of you understand this? Right? Very good. Very quick. Yes. So how do I write in terms of quantifiers? I can write like this. X such that. Okay. What is a quantifier? Ayush?
Yes, sir.
If x is in the set, what is a quantifier?
Existential.
Yes, there exists, right? When can x be in the set? See, why 4 is there? Because 4 is equals to 2 square. Why 9 is there? Because for 9 there is n equals to 3. Some n exists. 3 square. Okay. So there exists n in n such that x equals to n square. Is it fine for everyone? Yesterday we had confusion, right? Whether to write for all or there exists. And the correct answer is there exists, not for all. Right? Here we say that it is S is of the form n square for all n in n. But when does some element belong? What is this property in terms of quantifier? See, why 9 is there? Because 9 equals to 3 square. So some natural number exists. I cannot say 9 equals to n square for all n. This is not true, right? 9 is not equal to 2 square. 9 is not equal to 4 square. 9 is not equals to 5 square. So some natural number is there. So I can write x equals to, or sometimes we also write like this, x such that x equals to n square. And here we write in words for some n in n. So this what for some n in n means this is a quantifier. Those who understand say yes. Some have already said yes. Right. So the quantifier, if we write like this there exists. Okay. Not for all. Okay. Now coming to what we are discussing, no, set of rational numbers. This is what we had written x, where such that there exists some integer p and an integer q. When I write comma, I say and, right? All these are property and all these three conditions. Q is non-zero such that x is of the form p by q. And then we had another set S, okay, where we wrote like this. We can also use PQ notation, but just to avoid confusion, I am using it A and B, just like yesterday. So what was S? There exists an integer A, and a natural number B such that X is of the form A by B. So our question was whether S equals to Q or not. So for this, we need two things, right? First thing, what we proved was S is subset of Q. Okay. How did we show S is subset of Q? Did you discuss yesterday? Yes. Room number 5, Shivam.
Sir, we took an arbitrary element of S and showed that it belongs to Q.
So if I take any X in S, then what can I say?
Then X is in the form A upon B by the definition of S.
Yes. So then there exists A is an integer, B is a natural number, and X is of the form A upon B. Okay, good. Now?
And we can choose P is equal to A and Q is equal to B.
Yes, very good. P equals to A and Q equals to B. Okay. So what do we get? Sorry. So I can write X is of the form
P upon Q.
P upon Q. Okay, where P is an integer. Yes, P equals to A is an integer. What about Q? Q is equals to B, and B was a natural number, so B is also an integer. So P is an integer, Q is an integer. Third condition was Q should not be 0. Is it the case, Shiva?
Yes, sir.
Yes. Why it is the case?
Because in natural numbers, number begin from 1.
Yes, because it's a natural number, so Q is anyway non-zero. Q equals to B, and B is a natural number. So all these three conditions are satisfied. I have just simply taken P equals to A, and Q I have taken B. So I have S is subset of Q. Okay, this was I think clear yesterday also, but those who followed this say yes. Yes, Vishal. No raising hand. Okay.
Sorry, sir.
No problem. No problem. Yeah, कोई बात. फिर से आ गया देखो विशाल. Don't click again. It's now removed. Okay. Now we want to show S is subset of. Sorry. Now we want to show that Q is subset of S. So where do I start? Can anybody help? This was some confusion, right? There yesterday. Q is a subset of S. How do we start showing that some set is subset of? Start करना है. Why only few? You already discussed, no, yesterday, and then you have revised today also. Why only few? Just begin. Okay, room number 9, Rigved. Where do we start?
If we take an element from P, which is an integer.
No. Where do we start? I want to show that Q is subset of S. So from where do we start?
X belongs to Q.
Yes, very good. So let X belongs to Q. X belongs to Q. Then?
There exists P in Z.
Yes, very good. There exists P in Z.
And Q in Z.
Q in Z.
Where Q not equals to 0.
And Q not equals to 0 such that?
X equals to P by Q.
Such that X equals to P by Q. Okay. So I started with, thank you, Rigved. So I started with X in Q, right? And so I know that there is an integer P, there is an integer Q, Q is non-zero such that X equals to P by Q. What do I have to show? I have to show X is in S. For that, what I need to show? I need to show that X satisfies this property. So what do I need? I need two things, right? One integer and one natural number such that X equals to A upon B, where A is an integer, B is a natural number. Can you give me A? What should be my choice? A. I have to give now A and B such that
Be an integer.
but what should I take? It will be an integer, I know. I want an integer. Okay, Sakshi.
यस सर यहाँ पे पहले ए पी को ए के इक्वल बताना होगा, फिर क्यू को बी के
Okay,
इक्वल.
no, wait. Okay. Sakshi says that I can take A equals to P because I know X equals to P by Q. So P I know. I can take A equals to P. Can I take A equals to P? Let me clear the feedback. Now answer. Can I take A equals to P? Is there any problem? अभी problem नहीं है ना? Just want to make sure can I take or not. Yes, Shivam.
Sir, it depends on Q.
No.
If Q is negative.
That is fine, but is it possible?
हाँ,
इधर तो problem नहीं है, right?
it's possible, sir.
Okay, yeah. So that's possible because I just want an integer. A should be an integer. My P is already an integer, I can see. P is an integer, A is an integer. So I can take A equals to P. Fine. Now the next step is, so numerator is done. Now if I can I take B equals to Q? That is the question. Is it always possible to take B equals to Q? And then there is simple, then I'm done. Just like in previous case. Here we have taken P equals to A and Q equals to B, then we are done. Now here, is it possible? If I'm given P by Q, can I take A equals to P and B equals to Q? So now this is the question. Okay, some are saying yes. Kundan, B equals to Q, can I take? Room number 6, Kundan. Okay, room number 9, Vishal.
Yes, sir. B equal to Q we can take because we have a condition that Q does not equal to 0 and B is a natural number, so that B starts
No,
with A
wait,
and Q
Vishal.
also.
Just wait. I am given Q. Okay, what is Q?
Q is a integer.
Integer. Okay, and also I know that Q is
Does
not
not equal
equals
to
to
0.
0. Okay, can you give me an integer which is not equals to 0?
1 2 3 dot n तक.
ना, वन एक ही चाहिए, कोई भी एक फिक्स करो. Fix 1. 1. Okay. If Q equals to 1, I'll take B equals to 1. And B is a natural number. I am done. Okay. Can you give another integer?
5.
5. Okay. Then also natural number, fine. Okay. Can you
Yes,
give
sir.
another integer which is non-zero?
6.
Okay. But not now this side. Now take on the other side. Can you give that?
-6.
-6. Now if Q equals to -6, can I take B equals to -6? Can I take B equals to -6? I want B to be a natural number. See, I wanted A to be an integer. I have taken P. Fine. P is given to be an integer. Now B, I want a natural number. Can I take Q? So how many possibilities are there for Q? Rani?
Yes, sir.
How many possibilities are there for Q?
So there are two possibilities.
Yes, what are the two possibilities? I'm given this information. So what do we know?
So first, Q is not equals to
Q is not equals to 0, I know. Now then, if Q is not equals to 0 and it is an integer, what are the possibilities? Q can be?
it may be positive and negative.
Yes, if Q can be positive or Q is negative. Fine. Good. Very good. Okay. Room number 8, Parul.
Yes, sir.
If Q is a positive integer, can I take B equals to Q?
Yes, sir.
Yes. Why? Because then it will be a
A
natural
natural
number.
number.
Yes, yes. So then I take B equals to Q. So I'm done. Okay. In my first case, P can be anything. I'll take A equals to P. I'm happy. I wanted an integer. P is an integer. I can take an integer. If Q is non-zero, so only two possibilities for Q, either positive or negative. If it is positive, then I know it's a natural number. So I can take B equals to Q, then it is done. How many of you are clear with this? Then there is no
Yes,
problem.
sir.
I can just click yes or no. Those who are clear. Good. So if Q is positive, I don't have to worry. I can just take A equals to P and B equals to Q, and I'm express this as A by B, and B is a natural number. Done. Now the problem is here. What if Q is negative? I cannot take B equals to Q because B has to be a natural number. Then how do I write P by Q? That is my question. Okay, P by Q where Q is negative. For example, I can take 2 upon minus 5. Then how do I write? Is it possible to show it is in S or that element does not belong to S? 2 by minus 5, S में आएगा कि नहीं? That is the question. Can you somehow write like this, some integer and some natural number? Krishna?
Yes, sir.
Yes. How do I write? Yes. Do you have any
Sir,
answer?
if Q is negative, then minus Q will be positive. Then minus Q belongs to natural number. Then P by Q written as P by minus of minus Q, such that minus P by minus Q. So minus P belongs to Z and minus Q belongs to natural number.
Okay.
So minus P, yes, sir.
Okay, thank you. Yeah. So what Krishna says, Q equals to minus 5, then I can write minus Q. Okay. So minus Q will be minus of minus 5. This is positive. Okay. Somebody's mic is on. Charvi. Yeah. So then minus Q is a natural number. So I'll take B equals to minus Q. Then no problem. B is a natural number. How many of you understand this? Just I've taken B. I'm not talking about A. Okay. The problem was negative integer. So we can write minus of Q. So B equals to minus Q, then it's a natural number, positive integer, right? Okay, now the question is what should be my A? I want to write now, I want to give A. What should be my A so that this P by Q equals to A by B? Okay, X is of the form P by Q and now I want to write A by B. B is a natural number which I have taken to be minus Q. So that problem is solved. अभी ये क्या लूँगा? Yes, Pritika?
So I have a doubt.
Yeah.
Are we talking about a reduced form of the rationals or any form?
I don't know reduced form. Now just think this is my number. I don't know what is reduced form. So this is my number 2 upon minus 5. How do I show it belongs to? Do you think it belongs to S?
Yes, sir.
Yes. Okay. So why does it belong to S? The problem was if I want to show it is in S, I have to show it is of the form A by B. Okay. Now is it clear? So now the question was what is B? B was negative. So Q was negative. So we can take B equals to minus Q, then B is a natural number. Now I have to choose A such that A by B equals to P by Q. Okay, you also have answered here also. This set you all agreed. This is 2 by 4 minus 1 by 2, 1 by 2. You gave me only one element. 1 by 2. So you know what? Kundan, you have question?
Yes, sir.
Yeah, क्या question है?
Sir, if b equals to minus q and q belongs to integer,
Hmm.
if we take as example 2, q equals to 2, then
नहीं,
b equals to minus
this is the case ना कुंदन, ये तो हो गया. B q was greater than 0. I have taken b equals to q. Okay. And now अभी
then
हमारा
why
केस क्या है? This is the case.
we have taken as b equals to minus q? Is
Because
this
q is less
possible?
than 0. Q is less than 0. Here I have taken b equals to q. It's a natural number because q is greater than 0. Are you following, Kundan?
It means that here are two cases. If q is to 2,
That's what I said. Q is non-zero. So there are two cases, right? What are the
okay,
two cases? Non-zero integer, either positive or negative.
like negative.
Yeah, if it is positive, I can just, it's a natural number. I can take b equals to q, a equals to p, and I have a by b. I'm done. Fine. Directly p by q, I'll take this is a, this is b, and I'm done. Yes?
Okay, sir.
Now the question is minus q. Then what Krishna said, I can take q is less than 0. I can take minus q as a natural number. So now if my b is minus q, what should be my a? That's a question. Nandika, do you have an answer? Just give answer directly.
Minus
Yeah.
p.
What should be a?
Minus p.
Yes, good. A equals to minus p. Then what is a by b? Minus p, what I have taken b? Minus q. What is minus p upon minus q? You already said, no? Minus 1 by minus 2. You already said it is 1 by 2. It is repetition. So this is p by q. Already x was p by q. I have written x is in the form of a by b. This is an integer. Minus p is an integer. P is an integer. So minus p is also an integer. Q is negative integer. So I have taken minus q. So it's a natural number now. So I have taken b to be minus q. How many of you are clear with this? Right? It's just that if this kind of number appears, we feel at first that this is not in the set. Here denominator has to be a natural number, something like that. But you already answered this when I showed you this. You already said that these all are same. This is 1 by 2 only. All of you agreed here. Right? That means this should be same as this. So then, and here also see 1 is given. Here I have written minus 1 square. It's not in the same form, but it may be in the other form. So here 2 upon minus 5 may not directly look like that it belongs to this, because we see that, okay, 2 is an integer, but minus 5 is not a natural number. But then you can express 2 upon minus 5 as minus 2 upon 5. So instead of p by q, I'll take minus p upon minus q if q is negative. Okay, so this was the discussion. I think now you can clearly understand this if you discuss this in the discussion.
Maybe they can take 30 seconds and
That's what I wanted. So now clearing the feedback. Take 30 seconds to
why
go
30
through.
seconds now? Because I know for a fact that none of you discussed this way yesterday.
And there's not.
अब समझ में आ गया करके छोड़ दिया है डिस्कशन में. You didn't discuss properly how to show that Q is a subset of S. So go through the proof now.
And always ask questions. So if I want to show Q is a subset of S, where do I start? Start with an element, okay? Ask questions like this. Take a break, 30 seconds. Go through this in your mind. When you are done, click yes. And if you have a question, I suggest you do it in discussion room.
So those who have not clicked yes yet, don't worry, but make sure you discuss in the breakout session.
Breakout room. Yeah.
Don't let the others say,
Proceed
go
without
forward.
you are being
Proceed
clear.
without discussing this. Yes.
Yes, Shivam.
Sir, are we taking A is equal to minus P?
I don't know. Okay, discuss. Did you click yes when I said, is it clear?
No, sir.
No. So what is the problem? Were you paying attention?
Yes, sir. I was just asking, whenever we took Q is equal to minus B, B is equal to minus Q,
Yes.
then we will take A is equal to minus P.
Is it what I said? Isn't that what we discussed? ये तो हमने डिस्कस किया ना कि नहीं किया?
Yes, sir.
हाँ लिखा हुआ है ना, already it's written.
Can you please repeat it one time?
No, I'm not repeating now. So many times I've repeated yesterday. Today I've repeated again. I said now you have to discuss in discussion room. Okay.
Okay, sir.
Okay. Let me. You are in room number 1. Room number 1. People click yes. Those who have understood. Room number 1. Okay. So 3 people have understood. Shivam, discuss with them. Is it fine?
Okay, sir.
Okay. Okay. So proceeding with this now. Okay. This you were already discussed yesterday, but yesterday some confusion was there, so I repeated. Okay. And I think I explained very slowly and clearly. So Shivam, pay attention now. Okay.
Sorry, sir.
Okay. So S is, I say, a set of students in this class. Okay. Who are the elements of this set? Click yes. Okay, room number 8, Parul.
Yes, sir.
Can you give an element in this? What is not in the set? Not in S.
Sir, mentor.
Yeah. So mentor, but I want one element, one person. So who is your mentor?
Sir, I don't know like the exact name, but I can give your name, sir.
Okay.
You are the one.
Whom you will give?
Sir, you. Sir,
Oh,
Jay, sir.
okay. So I am not in the set, right? Okay.
Yes, sir.
Any other element? Any other element?
So all the mentors in the
All the mentors, yeah. Yeah. So I see Yogita also. It's not in S. So I see Swapnil, right? So that means you're taking elements from where? If they are not from S, but where they are coming from?
sir in G2.
In G2,
I'm
yes.
G2.
Why did you look for G2 and not outside your teacher's name or somebody else's name? You looked for G2 because I said this, right? Students in this
Yes, sir.
class, right? So, so see, whenever we talk about set, right? A is a set. So it is subset of some set. Okay. Thank you, Parul. So it is some subset of some set, right? We consider universal set. X is universal set. When we say that X is not in A, so then where it is, right? It is some, in real analysis, our universal set is the set R, real numbers, right? In number theory, our universal set is set of integers. Okay. So if X is not in A, that means what? Right? Where X is coming from? We are saying X is in X. And we say that if X is not in A, then X is in A complement. So how do we write complement? If I want to write complement as a set, how do I write this? A complement. Room number 2, Sheikh Faisal. Room number 2, Sheikh Faisal. Yeah. Not audible. Okay, room number 3, Sumanyu.
So we can just say the elements are of the form X, where X is not part of A.
Where X is not in A, but where X is from? I can say X is
Is
from
in X, capital
yes.
X.
Yeah. So this is the complement, right? X is in X, but which is not in A. So this actually two condition, or we can write like this X such that X is in X and X is not in A. Okay. What if I say if X is not in A complement? If X is not in A complement, that means what? Jainam?
Then X will be in A.
How do you show that? So I'm writing like this, okay? If X is in A complement, then X is in A, right? How do we show this? So X, when does X belongs to A complement? This property is satisfied. All of you agree with this? Okay, X belongs to A complement means this property is satisfied. So X is not in this complement means this property is not satisfied. So what is the negation of this? X is not in A. What is the negation, Jainam?
There exists X, some X belongs to A.
No, X is not in A. What is the negation?
X
X is
belongs
in
to
A.
A.
That's it. So X belongs to A. Right? Some element X belongs to A complement. That means this property is satisfied. Property said X is not in A. So it is not in this, that negation of this, just like this. Okay. So that means what? X is not in A complement means it is in the complement of this. Okay. So what I have shown? I have shown that this is subset of A. All of you understand this? If you don't understand, you can say no. Right? Just simple property. This is how we write. Yes, Raj.
So A complement to complement is a subset of A or equals to A?
But what I have shown, I have right now shown only this much. If X is in this, then X is in A. But in
Okay,
fact, they
sir.
are equal. How do I show? For that, I have to show if X is in A, then I have to show X is in A complement. Right?
Okay, sir.
You can discuss this. How do we show this? So simple, yeah. Yes, Aisha.
So can we write it as X belongs to capital X such that X belongs to A?
X belongs to capital X.
X such that X belongs to A.
Okay, what is this set?
The same as A na A complement. A complement which is A.
No,
X
this
does not
is
belong to A complement. Can we
X
write it?
does not X does not belongs to A complement means what? So the negation of this, right?
Yes. So
So X
this
belongs to
statement
A.
is it correct?
Yes, the statement is correct. So in fact, we have equality, right? Okay, so I have now, let's say, two sets. We are taking some two sets. Okay, they are subset of some universal set. and we take union. So how do I write union? We know, right? X is in X such that Anwar.
X belongs to A or X belongs to B.
Yes, X belongs to A or X belongs to B. Okay, so if I write like X, sorry, if I write like X belongs to A union B, okay, then that means X is in A or X is in B. And what do you mean by X is not in A union B?
X belongs to X such that X does not belong to A and X does not belong.
It cannot be in any of them, right? X is not in A and X is not in B. Okay, good. So if it is not in the union, what we can say? Then where it
Belongs
is?
to the complement.
Yes, it belongs to, yeah, good. Thank you, Anwar. Then I can say that X belongs to A union B complement. Okay. Ankita?
Yes, sir.
Yes, if X is not in A, then where is X? If X is not in A, can you give a set where X belongs to this?
Then if X is not in A, then X belongs to A complement.
Yes, A complement, and X is not in B, that means what?
Then X belongs to B complement.
X belongs to B complement. And if X belongs to A complement and X belongs to B complement, then what we can say?
Then X belongs to A union B complement.
No. So how do I write intersection? What do you mean by this? X belongs to A intersection B.
Yes, sir. Sorry, sir.
No problem. So that's also a way to see it. So how do I write this? X belongs, what does this mean? X belongs to A intersection B. Yes, Shivam, what does this mean?
X belongs to A and X belongs to B.
X belongs to A and X belongs to B, right? So what if I have X belongs to A complement and X belongs to B complement? That means what?
Bhakti.
Can I write? Yeah, Bhakti.
Yes, sir. X belongs to A complement or X belongs to B complement.
No. See, Shivam just answered. X belongs to A intersection B means X is in A and X is in B, both, right? So here what do we have? X is in A complement and X is in B complement. So what we can say? Sonali?
X in A intersection B complement.
A intersection B complement. How did we get? Okay, tell me this. X is in C and X is in D. Then what can you say? Where is X?
X in C complement and
Oh, no. There are two sets, C and D. If I say X is in C and X is in D, then where is X? Where can I say? Can I say is it in the intersection?
C intersection D.
Yeah, C intersection D. Can I say this?
Yes, sir.
Yes. Okay, now my C is this. And my D is this.
X in E C union B. No, C union D in complement.
No, this is C. And this
Jay,
is
in
D.
between the two lines, you just rub it off.
Okay.
C and D wala. Yeah. Now tell.
X in A union B complement.
That is there here. It is not in A union B, so it is in the complement. That is fine. Now I am saying this side. X is not in A so X is in A complement. And X is not in B, so X is in B complement. So now if X is in A complement and B complement, can I say that it is in intersection?
X in A or X in B?
No, let me ask somebody else. And see, yes, Siddhi.
Yes, X belongs to a complement of A, intersection complement of B.
Yes, X belongs to A complement, intersection B complement. It is in both, right? So it is in the intersection. This is what we wanted. Isn't it true? Yes or no? Right, this is thing. If it is in both, then it is in the this is in the intersection. Okay, so what did we prove? Did we do anything? Where did we start and what did we prove? Can you say? कहाँ से शुरू किया था? Room number 4, Tanya.
We can say that A union B complement is subset of A complement intersection B complement.
Okay. So Tanya says that we have shown A union, sorry, we have shown that A union B complement is a subset of A complement intersection B complement. How many of you agree with her? What did we prove? Where did we start? Yes, Ayush.
So we proved the equality, right? We proved that one is a subset of other and other is a subset of the first one, right?
Okay.
Did you?
Where did we start, Ayush? Start
We
कहाँ से
started
किया?
from A union B complement. X belongs to A union B's complement.
Yes, very good. So we started from this. So I started this. If X belongs
Okay, I
to
see it now. Yes.
X belongs to A union B complement.
So yes, we proved the subset.
So then we discussed that if it is in the complement, yes, good. Sheikh, you want to change your answer, Anwar? Do you realize now? We started with this. Okay. X is
Sir,
in,
but aren't
yeah.
the two statements equivalent? Aren't the two statements equivalent saying that?
No, my question is, what did we prove yet? Have we proved that they are equal?
Yeah, we proved that it's
We just
Yes,
started with, so we just started with, I'm not saying that they are not equal. I'm not saying that. Okay, I'm saying that we started with saying that X is in not in A union B. So that means X is in A union B complement, right? So X is not in A union B. Now what is the negation? We know X is in A union B. That means X is in A or X is in B. Right? So negation will be X is not in A and X is not in B. If it is not in A, it is in A complement. If it is not in B, it is in B complement. And X is in A complement and X is in B complement. So X is in A intersection B complement. So you prove this. If X is in A union B complement, then X is in A complement intersection B complement. All yes now? Okay. What should be our next question? Already you have got, you know? What should be our next question? Tanya?
So to prove the equality, then we will show that A complement intersection B complement is subset of A union B complement.
Okay.
Jay sir asked you what should be your next
My
question.
next question should be what? That's a precise thing. One thing I have shown, this is what we have proved. If I start with here, then I can conclude here. So this means subset. Okay. Jairam?
Yes, sir. Our next goal should be to prove that the A complement intersection B complement is subset of A union B union complement.
Yes. So
It is-
where if
Jay, just a second.
Yeah.
It is a statement, right, Jairam? What is the question?
Yes.
No, but they don't know whether I'm asking about this or I'm asking about this. Okay, let me be precise. I just said this is what we proved. What is our next question? Okay, if today is Saturday, tomorrow is Sunday, then what is the question you can ask? There can be many questions you can ask, but I'm just asking one. Do you have any idea, Adya?
Yeah, so your next question would be if we start from x belongs to E complement intersection P complement,
Yes.
then if x is also belonging to A union P ka whole complement.
Yes, very good. So this is a question, right? We don't know that is true or not yet. We have not proved, but this is our next question. Am I clear? Now, do you see any relation between these two statements?
See, I would think that most appropriate way would be that whether the converse of this statement is true.
Yes.
Right? We have proved if P then Q. Can I prove the converse? Whether the converse is also true. Okay. And what is the converse is what you have said.
Yeah, so this is the converse, right? If P then Q, so if Q then P. So this is the converse. Okay, so now we want to prove this. Then we can revise the entire argument. So let me write here now what we are proving. If
Jay,
X, yeah.
let us not do it without writing. Let
No,
them
I'm not going to write, just writing the statement. So that
Yeah.
this is the converse we are proving. But this time I won't be writing. We want to show this. Okay. Think about the proof. Or where do we start? Even if you don't see the proof, entire proof, but where do we start? Okay, room number 7, Ashwini.
Yes, sir.
Where do we start to prove this?
Starting from x belongs to A complement and x belongs to B complement.
Before, but then you have taken next step. What should be the first step? Already I said you, yes. Pradnya, room number 6.
Same answer.
Same answer, but what's most appropriate? Charvi?
So we first assume that X is in A complement, intersection B complement.
Yes. Okay. Yes. Thank you, Charvi. That's it. Yes. Let X belongs to A complement, intersection B complement. That should be our first step. Okay. Then what Pradnya and all said that means that X belongs to A complement and X belongs to B complement. But first step is to start from here. Let X belongs to this. Okay. Now what is the next step? Parth?
Yes, sir.
Yes. What is the next step?
X belongs to A complement and X belongs to B complement.
That is already I said. Okay. Then what can you say?
Not belongs to A and X does not belong to B.
Yes, very good. If X is not in A complement, then X is not in A and X is not in B. So X is in B complement, so it is not in B. Yes. Priyanshi? You want to continue? X is not in A and X is not in B. Then what we can conclude?
Next is what belong to
Some disturbance is there. Ramesh?
Yes.
Answer.
X belongs to X belongs to not X not belongs to A and X not belongs to B.
हाँ वहां तक तो थे हम, अभी आगे क्या बोलोगे? what can you say there?
Then X not belongs to A intersection B.
Where do we want to go, Ramesh? Can you see the right hand side? Where do we want to go? Okay, room number 6, Khushi.
Yes, sir.
हाँ, continue. You see, whenever I call out your name, just say the answer. Don't say yes, sir, and all. Okay, you know where we are.
Sir,
Okay.
No, you guys are not paying attention.
Shubham, room number 7.
Yes, sir. Sir, X not belong to A intersection B.
No.
Oh, sorry, sir.
Okay, let's start
X
over.
belong.
Yeah, that's what I'm saying.
Sir, X
Ah.
belongs to A intersection B, not belong to A intersection B complement.
No, we want to show X belongs to A union B complement, right? This is where we are going. See, I'm starting again. So we start with an element X in A intersection. Let X belongs to A intersection. A complement intersection B complement. Then what can I say? X belongs to A complement and X belongs to B complement, right? X belongs to A complement and X belongs to B complement. So what does this mean? X is not in A, X does not belongs to A, and X does not belongs to B. It is not in A and it is not in B. A में भी नहीं है, B में भी नहीं है. Can it be in the union? It is not in A and it is not in B. Can it be in the union?
no.
No, right? Why? Because already see we have seen you are not revising. I've written union, right? See this. X is not in A union B. You already negated this. X is not in A and X is not in B. So it cannot be in the union. If it is not in the union, then where it is? It is in the complement of A union B. Those who understand say yes. Those who want me to repeat once again say no. Okay, Shivam. Yes, we'll ask somebody, okay, to repeat. Room number 8, Rahul.
Yes, sir.
Yes, can you now repeat the argument? Where are we starting? What is the first step?
Sir, X belongs to A complement intersection B complement.
Okay, next.
X is belongs to A complement and X is belongs to B complement.
Yes, next.
X does not belongs to A and X does not belongs to B.
B. Yes.
So the X does not belongs to A union B. Therefore, X belongs to complement of A union B.
Okay, very good. Room number 5. Ayush, do you want to repeat?
Yes, sir. So first we started with X belongs to A complement intersection B complement.
Okay.
So we can expand this and write X does not belong to A and X does not belong to B.
Yes.
Yes. So X does not belong to A and X does not belong to B, which means it cannot belong to the union of them because it does not belong to A and it does not belong to B.
Yes.
And if it is not in the union, then it is the complement of the union.
Yes, and what
Yes.
does it prove?
It proves that X belongs to A union B's complement.
No, as a subset, what does it prove?
A complement intersection B complement is a subset of A union B complement.
B complement. Okay, clearing the feedback now. Is it clear to all of you? Okay, take 20 seconds. I'm clearing the feedback. Think about the argument in your mind. When you're done, say yes. Okay, those who think they can discuss and clear in the discussion, say yes. Okay, good. Now, if I take if X is in A intersection B complement, then what can you say? What is the first step, immediate step? Yes, Vishal?
Yes, sir.
Immediate
If
step. If X is in the A intersection B complement, then
X does not belong to A and X does not belong to B.
wait.
It means that
Next step. What is this immediate step? If it is not in the complement, then where it is? If it is a complement, then where it is?
I'm not getting, sir.
If I say X belongs to a complement, what can you say about X?
X is in A.
Oh, can it be in A? Is it possible X can be in A and A complement?
No.
Both? So what can you say? X is in A or X is not in A?
X not in A.
Yes, X is not in A, right? So if something is in the complement, then it cannot be in the set. Is it clear?
Yes, yes.
Now tell. So if some X is in the A intersection B complement, then what can you say?
X is X not in A and not in B.
No. It's not the. Okay.
X does not belong to A intersection D.
Yes. X does not belong to A intersection B. Vishal, is it right?
Yes, sir. But I expanded it, and next step I tell them.
Okay. Let us expand this. X does not belongs to A intersection B. Do you agree with this, Vishal?
Yes, sir.
Okay. Now tell me, what does it mean by X belongs to A intersection B?
It means that X does not belong to. Oh,
No.
X
This.
belongs to A and X belong to B.
Yes, very good. X belongs to A and X belongs to B.
B.
Now negate this. Here it is belongs to, here it is not, does not belongs to A. So negate this.
X does not in A or does not in B.
X is not in A or X
Not in
is
B.
not in B. What you were saying?
Oh, sorry, sir. I get.
See, that is why we should go step by step. So all of you see this? Don't
Yes,
just jump directly. Go step by step. Okay, fine. So take slowly. Don't directly go into it. Okay, X is in the, this time is up, but let me take a minute or two to wind up. X is in A intersection B complement, so X is not in A intersection B. Now, if X is not in A intersection B, don't remember all this. See, I don't remember. If I forget, I just go to the intersection thing and I just negate it. So I just ask myself, what does it mean to say X is in A intersection B? So X is in A and X is in B, but here I have X is not in A intersection B. So it cannot be in A or it cannot be in B, right? If you don't see it directly. Okay, now my next question, if it is not in A, where it is? Room number 10, Rachna.
Sir, X belongs to A complement.
X belongs to A complement and
Or
or
X belongs to B complement.
then what we can say?
X belongs to A union B complement.
Okay, no, again you are X belongs
A
to A
complement
complement,
union P
or
complement.
yes, X belongs to A complement or B complement. See, don't see the complement, just see the or. X is in either this set or X is in this set. So where is X? It is in the union, isn't it?
Yes, sir.
So what is this? What did we conclude?
X
Then
belongs to
A
A
complement,
union P complement.
union B complement. Yes, that's correct. So what did we prove? We proved this. A intersection B complement is a subset of A complement union B complement. Okay, what is the next question? Next question. Converse. Right? Advait, next question.
Yes, sir. Next question would be if the converse is true.
Yes, and what is the converse?
So the converse says that if X belongs to A complement union
Yes.
B complement, then X belongs to A intersection B whole complement.
Yes. Then X belongs to A intersection complement of A intersection B. Okay, so discuss the converse. Okay, and both this you have to discuss everything. It's not just that whatever is given at the end you have to discuss. You have to go through everything. Make sure that you are confident when you are in discussion room. Try to give the proof yourself without writing. Okay, and if you have got the proof, make sure that whoever your friends in the breakout room, they can also give the proof. Then only proceed. Okay. So we have seen the complement and two operations. We have seen complement and intersection, and they do not behave well. Three operations actually: complement, union, and intersection. If we take first intersection and then complement, we don't get intersection. We get union of their complements, right? If we take first union and then take the complement of A union B, we get intersection of their complements. So this is the interaction of complement with union and intersection. Okay, Gokul, I stop here.
Thanks, Jay.
Yeah.
We'll stop.
Jay, one suggestion.
Yes.
In both places, you can maybe add a question mark before you upload the transcript. Where we are asking the converse. We are asking, right, what is the next question?
Yes.
Huh. We haven't proved it, so we can just put it as a question.
That's a question only. We have not
Yeah,
proved,
yeah.
right? Yeah.
Yeah, yeah.
Okay.